Alright, so this is lecture 3B on analyzing data and inferring results. In this lecture, we're going to be talking about analyzing the data using correlation. Correlation is measured by what's called an R value. So I'll introduce R values to you and what that means. I don't expect you to calculate them, but I do expect you to know what they are. Then we'll talk about correlation versus causation. Just because something's correlated doesn't mean it's the cause, and that's something you need to recognize. Then we'll talk about other statistics that you can use that, while very simple, can be very powerful. And then lastly, we're going to talk about using a graph to infer and extrapolate data. Okay, so here we go. Analyzing and correlation. Okay, so correlation occur together. That means it occurs together in a way not expected on the basis of chance alone. Okay, so that means it can't randomly happen. That's what we're talking about when we're talking about correlation. And it's measured by what's called the R value. Now this is a mathematical statistic. You can plug it into a calculator or an Excel program and it will draw the correlation line for you. That's something we might use later this year, but for right now, I just expect you to know what an R value is. Okay, and really this is how well it fits to a line. Okay, so if you look in the upper right-hand corner there, it has some values of R values. Now R value can be positive or negative. If it's a negative, if it is a negative slope, like the very first picture there, that's R versus 0.90. Now the closer the R value is to 1 is the more closely it fits a line. Okay, so the first one is R negative 0.950 because it's a fairly good line and it's negative. The second one is R 0.5, and you can see it's a little bit more spread out. And the last one is R value of 0, meaning there's no correlation there at all. You can't draw any line through that would really make sense. Or another way to think about that is there are unlimited number of lines that could fit through that data. You could draw a line any direction and it would be equal. On the bottom you have positive R values. Okay, so you have a 0.5, a 0.9, and you see almost a perfect line there. And R value of 1 is the last picture. Okay, so know that R value is how correlation is measured. The closer it is to 1 is the better it fits to the line, or the better the data is. Now one last thing here is a direct correlation. This is on one of your handouts. That's where the correlation is positive, and an indirect correlation is where the line would be negative. Okay, correlation versus causation. Just because something is correlated doesn't necessarily mean it's caused by that. Example 1 here is a perfect example. It's kind of the classic example of this. If you look at if you graph the amount of ice cream sales per day on a temperature, right, you would see that it increases. Also, if you graph the number of home burglaries versus temperature, you'd see that it increases. So does that mean that burglaries and getting ice cream are somehow related? Are people going out to get ice cream and their house is getting burgled? Okay, so no, that's not the case at all. They do share the same variable there is temperature. So as temperature increases, more people get ice cream. As temperature increases, there are more burglars out possibly to be out, stealing stuff. Okay, so just because something is correlated doesn't mean that it's caused by that. It could just be an interesting coincidence, like this ice cream example. Another example I have, and this always gets me, and you see it in the news. Okay, video games, right? Video games plus, somehow you hear it in the news all the time. A teenager who's playing 15 hours of video games, who's hopped up on Doritos and Mountain Dew, killed some people, right? And it was like, oh, it's the video games that's causing that, right? Well, not really. It's correlated, but really, if you look at down here, it's probably, a parent who allowed their child to play 15 hours of video games, and have access to a handgun. That's probably really the causation there. The Grand Theft Auto is not. It's just correlated. It's not the cause. And you'll see that when Grand Theft Auto comes out. You'll see that in the news for sure. So just look for that and just know it's correlated, but it's not the causation. All right, so some other statistics that can be very powerful. And in this example, I have just a data table here that shows the amount of fertilizer in grams and plant height. And so as we can see, the more fertilizer you give these plants, the more they grow, the higher they get. So some things to look for when you're looking at data is first the sample size, or N. So this is the number of observations. Okay, and in this example we have 6. Typically, the more observations you have, the more relevant the data. Okay, so 1,000 observations that are related are better than just a few. And you'll see this a lot of times in like when people try to trick you, they'll only have a very few observations and say that, oh, this is like happening. Okay, you can't say something is happening until you have several observations. Okay, the next one is mean or average. Okay, so the average, what's the average of this data? So here I have the average plant height, and you take an average by adding up all the categories and then dividing by the number of categories. Okay, so I added up all the plant heights. There's 7 measurements, so I divided that by 7. I came up with 16.6 centimeters is the average height. Okay, the median or midpoint. Okay, so this is where's the middle of the data. Okay, sometimes it's the same as the mean, sometimes it's different, and that can be significant also. So again, there's 7 data points. I put them in order, and then we find the middle one is 16. And then the range. The range is important because it's the difference between the extremes. Okay, so the 2 extremes are 10 on the low side and 23, so I've just subtracted those 2, and you find the range is 13. Now, when the range is extreme, okay, so let's say the range was, I don't know, 50 or 60, something like that. That could indicate either you have problems with your data because you have these extreme ranges, or it could be that if there's a very significant correlation. So that's always something to look at very closely, is that range. Okay, so inferring and extrapolation. Now this is really where the strength of graphs comes in, because it can be hard to infer or extrapolate just from a data table. Okay, so here's that same data table from the previous slide. Okay, amount of fertilizer in grams and plant height. And let's say I wanted to infer what the height of a plant given 7 grams of fertilizer. Now I didn't give a plant 7 grams of fertilizer in this experiment. Okay, but using the graph, and you can see that this has a pretty high degree of correlation in the graph. Okay, we can look at 7 and we can see, we would expect a plant to be about 15 centimeters. Okay, this can be a great way to actually check your data. So if your graph shows this, 7, go ahead and do it, like give a plant 7 grams of fertilizer. And if it is 15, you know that you have a very high correlation, or your data is very good. Okay, and then extrapolation. Inferring is when the data is inside the range values. Extrapolation is where you're going outside of those range values to make a prediction. Okay, so the question I have here for that is, what height might a plant be given 16 grams of fertilizer? Okay, so my maximum value was 14. So what if I give it more? What would we expect? And if you just extend a correlation line out, you can see what you might expect. So in this example, it would be 24.5 centimeters is what we'd expect. Okay, and again, you can test that and see how well your graph fits. And that's part of being a good experiment. Okay, so that's what I have for you today. Okay, we talked about correlation. We talked about some other statistics. We talked about correlation versus causation and inferring extrapolation. And again, if you have questions, don't hesitate to come talk to me in class. Thank you very much.